For more information on the Toronto Audio Engineering Society, go to TorontoAES.org. There you will find notifications on our upcoming events, past events, Masters of Audio, and our member showcase. The Toronto AES is brought to you by Solotech, Gare Audio, Sonotechnique, Bell Media, YSL Pro, Electrosonics Canada, BRTB, Global USS, Adamson, Lawo, avshop.ca, Q5X, and the executive team of the Toronto Audio Engineering Society. All right, I am joined by Ike Zimbel. Ike, are you there?
I am here.
Ike, it's fantastic to see you, my friend. Happy COVID, I like to say. Did you get vaccinated yet?
Yep. I've had the first shot, and it was fine. Didn't really wasn't much of anything to worry about.
Good.
And yeah.
No, not yet. I'm not vaccine age yet. I'm not in a hot zone yet, so I'm doing all right. But I'm excited for the world to take off again, and for maybe a summer to happen. Maybe there's going to be some festivals of some sort and some events happening. Are you starting to see work pick up, Ike, or what's happening here?
I've got a consulting thing I'm going into next week, and starting to hear a few overtures from the States and stuff, but that's complicated for us right now because of the border and stuff like that. And so I don't know. I this whole time has been kind of restful, and I'm looking to get back into it in such a way that I'm not killing myself. So we'll see how that goes.
Good. Well, yeah. Ike, sorry, I should introduce you. Ike Zimbel, you're technician extraordinaire based out of Toronto, Ontario. Here, you're a valued member of our Audio Engineering Society section here in Toronto. Thank you for joining us and taking the time to have this is a pre-chat. We're doing a pre-chat before the event on noise.
Okay.
So, Ike, you've had your hands in pieces of equipment since you were a small child. You it's in your blood. How did you get involved in audio, and why is the craft of audio engineering in your blood?
That's an excellent question, Anthony, and I'm glad you asked it. Thank you. Next question. No, I just reminded of it now. Actually, was when I moved to Prince Edward Island when I was 10. We lived in a small rural community there, and we had a youth group, and one night, whenever we got together for a meeting, and we thought, let's have a dance. And so I volunteered to do the music for it. And so I had a sound system at home I called the Ultimate in Home Mono, which was like a portable cassette recorder, and I had figured out how to solder and how to solder up an 1/8-inch mono jack and have an extension speaker on it.
Nice.
And I thought, well, if it's going to be it was the old schoolhouse was our community hall, and I thought, so I'll need to hook up more speakers. And my one weak point in that plan is it didn't involve an amplifier. And so the dance was a bit of a bust, but I kind of made me want to do it better.
Oh, yes.
And so I did end up getting an amplifier. The very first amplifier I got was this like really dangerous open chassis 3-tube thing that
wow.
I think had been harvested out of like an old jukebox or something.
Wow, it wasn't like an ICO kit.
No. Like
that would have been an upgrade.
no, it was something that it was meant to go inside something else. So it literally had like an open frame, so you could stick your fingers in amongst the high voltage wires and stuff like that. Just a piece of zip cord coming off of it for a cord and everything like that. So that was my first amplifier.
Man.
And anyway, I turned that into a business. I mean, by the time I was 14, I guess I had an agent, and I had to hire guys that were old enough to have their license to drive for me.
Of course.
And was doing dances on, usually it was like, it wasn't every weekend, and it definitely wasn't, two a weekend. It might be either a Friday night or a Saturday night, and
right.
and it was, I don't know, about $100 or something like that. The medium was
that's with PA? With PA? You $100 for DJ with PA delivery?
And lights. And lights, man.
Lights?
Yeah. And the lighting thing, the lighting thing, my first lighting console was the dash panel out of our disabled Citroen sedan.
Wow.
And because I was afraid to deal with the big volts, but eventually I got over that, and it was like garden variety colored floodlight bulbs and stuff. And then eventually we made our own flash pots and bought a strobe light somewhere, and the real big guys had like cop lights and stuff like that. I couldn't afford that, but anyway, I did that for until I was 17, and then I got an offer from a local band who were doing basically the same gigs that I was doing, like high school dances mostly, and the same thing like Friday and Saturday nights, and they asked me if I would like to come and mix for them, and I think before that I had one or two times done something of that nature, but but anyway, I eventually agreed to do that. The other thing I forgot to mention, the summer that I turned 16, I got a gig as a stagehand at the Confederation Center in Charlottetown. So, and I mean, that was an incredible introduction to the world of show business, like
right.
to be involved in professional theater on that level. For a whole summer. So I'd been around it, and I had, seen the little Neve console which I guess would probably be like a BCM 10 or something like that they had to mix out in the house with, and they had another one up in the booth, and it was all, at the time, it was all area miking. They were using mice. Do you know what mice were?
Yeah, like a PZM boundary kind of thing, or like a crown.
Except it was like a either a 635A or an RE10, maybe. I think an RE10 inside a foam holder that you would lay them down on the stage like that. So boundary idea, but much bigger gap than a PZM.
Lots of noise, not a lot of signal.
I don't know. They worked fine. They worked just fine. But anyway, so to have experienced the sort of professional part of the business before I started, working with bar bands and stuff like that. I mean, on the one hand, it was a great education, and on the other hand, it was like it made for a lot of friction working with the bar bands because they were such jerks for the most part. It's like, wow. It's time to go on stage. I don't feel like it. No, I gave you a 5-minute call. Let's go.
Yeah,
because I was used to like half hour, 15, 10, 5 places. Let's do the show every night. Yeah. The show came up at 8 p.m. every night.
Yes,
and
in a theater.
And the summer that I was 17, I ended up, and this was the beginning of a long tradition of getting fairly intense gigs on like no notice whatsoever. I got a phone call saying, "Hey, how would you like to be tech director for our summer stock theater?" "Oh, that sounds interesting. Can you come now?" And or like tomorrow or something like that. And I ended up, they had opened their season. There was a technical glitch in the opening night of a show. It got a bad review, and the guy that had been doing it quit, jumped in his sports car, and went back to Nova Scotia. And so I went into, and this was just lighting. no audio. But I went into this without having seen either of the two plays that were up and running, and then had the final tech rehearsals and opening of the third of the three shows in repertory. So it's not
Jumping in,
read the script. No,
Yeah. Well,
anyway.
It's a lot of improvising, and your career has had a lot of successes when it comes to solving problems. You've had, and we can talk about, we'll do an Ike Zimbel night. We try to have you at least 3 times a year, Ike. So you spent time at Sounds Interchange. You were a fixer of all things. You have gotten back into now that you're at home, not on tour. You've come off a couple of massive tours doing RF troubleshooting, spectrum management, and you're back at home, doing stuff on the bench. You were saying you're back into audio equipment. What kind of troubles are you solving for people, and what kind of stuff is keeping you busy at home now that you've got your bench back and up and running?
So it's been kind of a mishmash. I'm a little pickier about what I'll accept as something to work on these days, just because, not because I'm a snob, but just because I'm a little bit more woke to what is worth fixing and what isn't. Like for example, I'm not real keen on working on like what I call middle period digital devices, like PCM 60s and although I actually looked at an MXR delay for somebody recently, and it opened it up and it passed signal just fine, but it wouldn't delay anything. And it just happened that I've been listening to this podcast called How We Got Loud, and which is like a history of sound reinforcement. And it turned out that a guy that I knew, Joel Silverman, who I knew through Millennia Media, because I've been unofficially, I've been doing repairs for Millennia in Canada since about 2006 or 7. And anyway, I knew Joel from that, but it turned out that he had started his career in live sound, and we'd known each other for probably 15 years, and I had no inkling of that whatsoever. But he was interviewed for this show, and that's how I found out. And interestingly, he ended his live sound career with a show with Emmylou Harris at the then O'Keefe Center in Toronto, about the same week that I was in northern Quebec with the first band that I started working for up here in 1979. Anyway, he also worked at MXR. In fact, he left the road to go and work at MXR.
Cool.
And so it was like really great to have this thing in the shop and have somebody that I could actually call up. And we very quickly agreed that the reason that there was no delay coming out of it is the 4 slots inside it for memory boards were all empty. And anyway, so that one.
Well, the early digital stuff, they had techniques like they would put Dolby at the front end or DBX at the front end. They would do some really, really terrible math, and it would be noisy and grainy, and then they would do noise reduction on the output. Would they not? They would do tricks like that.
I don't know. I never. It's a funny thing. When I was actually mixing, when those things were, current, I had people going, oh, you should get a harmonizer, you should get a phaser. And I go, you know what? I'm trying to get rid of those sounds in the system. I'm trying to make the system not sound phasey to begin with. So I don't think I'm going to pay money to put something like that in, put it in deliberately. And that was just kind of my quest to I guess for kind of more sonic purity and that sort of thing. Wow. So, but in terms of repairs, I had somebody bring a Neve 1272 module that had been made into a mic preamp in, and on the subject of noise, put it on the bench and it's quiet-ish. But louder, more noise than it should be. So I think the initial measurements were something like, noise floor of -60 or something at full gain. and that's pretty noisy. I went through, I cleaned the switches, I tightened up a few things, I looked at this, I looked at that, and I got it where I was, reasonably happy. And I put it on the analyzer, and just listening to the noise floor, and I soon noticed that it was kind of cycling, and it kind of had what they call low frequency rocks in there. They're kind of,
Yes.
every few minutes. And so the noise floor was going from about, I don't know, about minus 70 something to about minus 50 something, which is still kind of down in the dirt. But on the other hand, it's a 20 dB increase in noise, Mm-hmm. And in that particular device, there's one amplifier card, and it had been recapped at some point in the past. And I said to the owner, I said, and I did go over the card. Actually, there was some things like somebody had done some cleaning up of the circuit board with a razor blade, and they'd slipped here and there. So there were some traces that might have had razor cuts in them, and maybe not, So I went through and I fixed all that stuff up, and it was still doing it. And I said to the owner, I said, it's virtually every component on that board is suspect. Every resistor, every capacitor, every transistor, and the circuit board itself.
Yeah.
It's all suspect. It's 50 years old, and any part of it could be, and I said, I can go through and I can replace every transistor in there. Mm-hmm. And that might make it better, or it might not. If it's the circuit board, which definitely showed some signs of having gotten warm here and there,
yeah.
So anyway, the net result of that was that there's a company that builds replacement boards, and I bought one, put it in there, and it's minus 80. Yeah. And so these are the kind of things that you have to kind of figure out. And
you have to give into it. It's like an all or nothing type of thing sometimes in these things. It's like the problem's either huge or it's one little tiny thing that takes you so much effort to diagnose that it's worth it just buying the replacement part to skip all that effort.
Yep.
So noise adds up, Ike, right? So if your preamp card is noisy and it feeds a line amp that's noisy and it feeds a piece of equipment that's noisy and it feeds this and you can never get rid of it. Like, it always adds up. Like, what are some of the other noises that are in these pieces of equipment that get transferred down the line and make them so difficult to diagnose and troubleshoot?
Well, I don't know about difficult, but I mean, one really common one is if you have a 2-channel device, for example, and you take the noise floor on channel 1, and it's say it's a respectable minus 80. Say I start to get happy when I see minus 80.
Okay, sorry. Let's talk about minus 80. Let's talk about the noise floor. And so, like, if you and I have spectrum analyzers on and we say nothing, that's the operating noise floor when you say that, like.
So this is in some ways it's complex, and in some ways it's not. And the other thing is that, for example, going back to that example, that 1272, I mean, that thing could have been doing that for years. And maybe if you went back and looked at some tracks that were recorded through it with cedar or some kind of really sophisticated noise analysis, you'd go, yep, there's her vocal, and down there is that little, low frequency thud that's going in and out, and maybe it was getting high passed out, and maybe, you know what I mean? So,
or tolerated because it had the Neve on it, and it's like, no, man, it's pristine, it's the Neve, we got to run it through and it was just tolerated because of that.
I don't even want to go there, but
fine.
The point is that when I'm looking at noise, I'm looking for trouble, because when I hook it up to my test set, the test set has 40 dB of gain on the front end of it when I'm looking at noise floor. And so that's basically the equivalent of taking like a line level device like an EQ or a compressor or whatever it is, and plugging that directly into a mic preamp. And so if there's noise there, you're going to hear it. Yeah. And the reason I'm looking for that trouble is because it's indicative of things. And so, for example, in that noise floor, there's probably going to be a dominant frequency, which my analyzer will call out. So if, for example, in that noise floor, the dominant frequency is 120 hertz, then that's a clue that there may be issues with filtering in the power supply.
Right.
So so again, a lot of times I'm looking at the absolute worst case to find potential problems.
Right.
And but the other thing, like the way I explain this to people, if people that still have consoles, for example, is if your noise floor is minus 80, well, look at the labeling on one of your faders. So unity gain is 0. If it's a channel fader, it's probably got like 6 or 12 dB gain above that. But going the other way, you pull it down, an inch, and it's down at maybe minus 15 or minus 20 or something like that, and another inch it's down at minus 40, and another inch it's down at minus 60, and maybe by the time at the bottom, the marking at the bottom might be minus 80, it might be minus 90 or something like that.
Yes.
So the point is that when you pull your fader down, that's how far, if your noise floor is minus 80, then that means that with that fader at 0, that the noise, if you've got like say an external mic pre or something plugged into a console channel, and that mic pre has a noise floor minus 80, then when the fader is parked at 0, that the noise floor is basically almost physically where the bottom of the fader is.
Right.
And but if it's minus 60, for example, and you have a few things that are, say, minus 60, and you are doing a fade out with your master fader, then, when you get that fader down to, the minus 60 range, that's where, the music is just going to go into the noise.
So yeah, and noise is cumulative, like you say. So if you have one noisy source and another noisy source and another noisy source, it adds up across things. So it's to your benefit to have a cleaner noise floor to begin with from start to finish, right?
Yeah, absolutely. And even though again, that noise floor may be way down in the dirt, it does add up, and when the noise isn't there, you're going to get more sonic clarity. You're going to get more of the music, more things like reverb tails, for example. It's so easy for reverb tails to get lost in the noise floor, and lost in other electronic issues that equipment has.
Yes.
That when you fix those issues, and suddenly you get more of the music for the same amount of money, it's like, whoa, it just all it. It's either going one way or another. It's either getting better or getting worse. So I always trying to push things toward better, and that's one of the reasons why I'm kind of looking for noise with a big magnifier on there is because the less of it is, the better, really.
Well, is it like a car? When a car is idling, you can really diagnose really fine problems, and then when it's revving at full speed, like you say, operating in that kind of range, it's a matter of proper power balance and operating levels and learning where to bury the noise demons in terms of your gain structuring.
It's a funny thing. I had somebody bring me some older power amps recently that they were going to use, or were hoping to use, for headphone feeds in a studio installation, and the complaint was that they were noisy. And if you just turn them on and hooked them up to a speaker, if you put your ear right up to the speaker, you could kind of hear something, but if you hooked it up to the analyzer and looked, the noise floor was about minus 68. And if you've got two little speakers pressed up right up against your head, you're going to hear that.
Yes.
And so I went, found the manual, found the schematics and stuff, and started looking through the spec to see what the noise floor was supposed to be, and the spec was given as 100 dB below full output.
Oh wow, yeah.
And I went, what does that actually mean? That means that when and that sort of goes with your car analogy, because all that means is that the amp doesn't get appreciably noisier than its noise floor when it's working.
Yeah.
So that means that when the speakers are loud and everything, you're not going to hear any of that hiss or hum or anything else that's in the noise floor. But that doesn't mean that it's not there.
Yeah.
So in that particular instance, the owner had some technical chops. He was going to try a few things, but those amps were potentially not a good candidate for headphone amps.
Yeah, there's also like in back in the day there were some bad practices for solving noise problems. Before we standardized on the pin 1 problem, and the AES identified that with Neil Muncy, and before we were pin 3 hot. Sorry, pin 2 hot. What am I talking about here? There were bad practices and things that were done to circumvent grounding practices. Are you, now that you're seeing some of this late 70s, early 80s equipment coming in, are you seeing remnants of scraped off paint and star points coming to equipment, or is that a thing of the past, as home studios are not necessarily thinking in terms of systemization like big studios used to?
Oh, don't even go there in terms of the home studio thing. I mean, that's a tough one. But in terms of equipment design, it's interesting. It's funny. Most of the stuff that I see from the 70s now is stuff that was designed properly in the first place, like Neve modules or API modules or Ward-Beck modules, or stuff that was designed first of all for professional use in the first place, and secondly was built well enough to last until now. But the stuff that that you're probably not going to see is the budget mixing consoles from the 1970s and 80s had terrible grounding issues. Because that is the period that when they did try and avoid connecting things to ground, with disastrous results.
Well, and that was like a post transformer, early op amp kind of thing. Is that what you're talking about there when you're talking about bad practices of interfacing, or circumvention of best practices? It's
an interesting thing. Like I am by no means an expert on tube equipment, and in fact, recently I connected with a guy that I'd known for a long time in another capacity, and it turns out that his hobby was kind of like, fixing guitar amps or making old, PA amps into guitar amps and stuff like that. And he knows a lot about the tube stuff. And I started, somebody brought me a piece of tube gear, if I couldn't get it in, 40 minutes, and say, okay, I'm going to move this on to my buddy here. And he has been telling me about, even grounding practices in the days of tube equipment, like, Fender amplifiers and whatever. And, the general practice at the time was, the chassis was ground, and anytime you needed a ground connection, you just went to the nearest tag to chassis, or in some cases just soldered right to the steel,
Right.
And it turns out that in some cases it's good to sort of take everything to chassis everywhere, but it turns out that there's surprise there's an art to it, and that you could also be building in built-in ground loops and stuff, and a lot of those older tube circuits can be made quieter by coming up with a star ground system for it or something like that. So it went from a thing where everything was grounded everywhere all the time to people trying to design equipment that had things grounded almost nowhere, with plastic bodied XLRs and plastic 1/4 inch jacks with plastic collars on them or insulators or whatever, because ground was like the boogeyman because of ground loops. And it turned out it took Neil Muncie and the AES committee and guys like Bruce Olson and Bill Whitlock and those guys to come up with the AES Pin 1 standard. But basically they were fixing a problem that had been created by people trying to circumvent ground loops and basically A, going about it the wrong way, and B, kind of going too far. Wow. And I was on shows. I worked with mixing consoles that had serious Pin 1 problems, and get to in one case it was Massey Hall, where this console had worked everywhere else and got it in Massey Hall, and it was like Hum City, and so that there was a lot of stuff like that. So, but again, I'm not really seeing gear with like massive Pin 1 problems, because most of that stuff wasn't good enough to become classics. And back to a slightly earlier question about things that noise things that you see. I started to talk about you might have a device that a 2-channel device, and you take the noise floor on channel 1 and it's minus 82 or something, and you take channel 2 and it's minus 78, and it's like, oh, it's 4 dB louder. Why is that? Well, the sonic, you look at the sonic signature of the noise, and there's more low frequency, like power line related low frequency stuff in there. Why is that? Because most of the time the power supply is on the right-hand side of the chassis when you're looking at it. And that means the channel 2 is closer to the power transformer if it has a linear power supply in it. Mm. And sometimes, and I'll certainly try this, but sometimes you can buy a couple of dB, or get the noise floors like a couple of dB closer by adding some additional shielding in there, like some extra steel. Mm-hmm. In particular, steel works quite well, and I will kind of I have various pieces of steel metal that I can and sort of move around inside a chassis while I'm listening to something and see if it will mitigate some of that. A lot of times it doesn't do much, but sometimes it does enough to, if you can get like 3 dB less noise by putting a piece of a piece of steel in there like that, I'll buy that.
You do it. You do it. Yeah. You do it for sure. Well, now that you're seeing laptops and you're seeing like things that are not made out of steel, you've got laptops that are made out of plastic or mm-hmm. extruded aluminum, and you've got FireWire and USB devices that are made out of plastic. Are you seeing, or are you in your colleagues and with your friends seeing like computers and these modern devices causing new kinds of noise in 2021? Are there new kinds of noise, Ike, that we should be looking out for?
Yeah, absolutely. There are, like in the same example of this, these power amps for this recording studio. I mean, they're in an equipment rack. They're in there with computers. They're in there with routers, internet switches, all kinds of stuff, and some of the newer power supplies or power amps have switching power supplies in them, and I was in there with the noise sniffer, and you could run this thing along just the power cable coming out of an amplifier, and it'll go zzz, or there's there's so many little fix-it boxes that to go from this format to that format, or an extra 4-port switch or something. There's so many of these little wall wart power supplies in there, and when you get the thing up to there, it's just like angry buzzing bees. And then you can go along different cables, USB cable or an ether, not so much Ethernet cables, but just listen to different cables and you go, there's stuff all over that. So there is this kind of EMF kind of noise swamp that's around that I think one of the reasons that some of this older gear worked as well as it did when it did is because it wasn't exposed to that stuff. You might have a rack of, you might have an amp room that had 10 amps in it, and that was it. And as long as the amps were shielded from each other, shielded from their transformers inducing hum in each other and all that stuff, yeah, that was good enough. And it was also much, much, much less likely to get into cabling. But this high frequency hash that's out there, particularly with every piece of wires and antenna kind of thing, it is definitely, there's kind of more of it around. So
you've said in the past.
You've said in the past that there's the age old debate or the feud between lighting and audio, and it was always related to the buzzes that they bring in to the system, and there was some kind of genuine friction that always exists, and you said something about susceptibility that changed my opinion of this argument or this fault thing. What did you say about that?
So there's a couple things. I mean, I was doing live shows in the late '70s, early '80s, and right up through to today, and back, in that last millennium, there was like a lot of genuine friction, kind of bordering on bad feeling between like audio and lighting, and I mean, everything, so many things have improved since then. I mean, just in terms of communication about, say cable management and that kind of stuff, and how to set up a show so you can take it down again without, tripping all over each other and all that stuff. Right. But one of the things at the time was, damn lighting guys, they make the sound system hum. And even at the time, I mean, I had done some lighting, but and I built lighting consoles for that matter. But I mean, I don't really believe in this kind of us versus them kind of stuff anyway, And so even at the time, I even as an audio guy, I knew that, so the lighting stuff makes noise. Well, really the issue is the audio stuff is susceptible to that noise.
Bam.
And that it's a susceptibility issue, which is what Neil, rest in peace. Neil used to say that all the time. We would talk about that, and the fact is that if you haven't done a good job shielding your device and dealing with the grounding and all that stuff, then it will be susceptible to noise. Yep. And another thing that I ran across is that susceptibility problems would develop, and in equipment that you would say, well, that piece of equipment doesn't have a pin 1 problem, but why is it buzzing? And I stumbled on this on shows a few times, and I'd go up on stage, talk to somebody, and they go, oh yeah, just a minute. They're going, try it now. What are you doing? Oh, we're just trying the ground lift switches on the monitor rack to see if we can make that buzz go away. And go, let me just see something here. And you go over to, in this case, it was a Yamaha PM 3500 monitor console. Yamaha had their grounding sorted pretty much from day one. Mm-hmm. And, but it was buzzing. And why was it buzzing? Because there were loose screws on the XLRs. And also the way they build the boards is, they'll have a panel, for example, that has all of the output XLRs on it. And that panel screws into the frame. And those screws were loose.
Yes.
And so, these guys are, flicking ground lift switches back and forth on the XLRs on the input to the monitor amps and going, is that better? Is that better? Is that better?
And, but the thing has rattled itself apart. And
give me a screwdriver. And I go, and like take out the Leatherman or something like that. Phillips screwdriver goes, twist. And you go, oh, how's that? Oh, that's way better. What did you do? Wow. And it's funny, I'll be on forums and people will write in, oh, I've got this noise problem and blah, blah, blah. I go, have you tightened up all the screws? People don't even answer. Yeah. They think like, oh, don't waste my time with that.
Who's this screwball here telling me to screw my screws back in?
Screw guy. And
that's a good one.
I had a piece come into the shop once that was had like a pretty serious hum on it. And I just kind of on a whim. I took a screwdriver. It was one of those deals that had like 4 big screws holding the front panel onto the chassis. And I don't know, maybe I picked it up. You feel something, or a little loosey goosey or something like that. I don't know. I just tightened up the front panel on it. Hum's gone.
Yeah.
That was it. No components replaced. No, this taken out, that taken out. Try to change this capacitor. Nothing. Yep. Loose screws.
Mechanical
in and out
noise.
in
Yeah.
20 minutes. Well, it's not mechanical noise. It's the integrity of the pin 1 chassis ground is degraded.
The shield enclosure is incomplete.
Yeah, and because the pin 1 problem is not taking pin 1 to the chassis, and so the pin 1 solution is taking pin 1 to the chassis. And if the mechanical connection to the chassis loosens up,
is via screw. Yes.
Yeah, it's by screws, and if those screws loosen up, then you have the pin 1 problem.
Fantastic point.
So
let me just dive into that. Yeah. So on a plastic XLR connector, what they do in order to make the plastic connect to the chassis is they run a piece of plastic behind. They run a piece of metal behind and around.
No. If they were using plastic XLRs, no. If they were using plastic XLRs, you're already sunk. That period. Yeah, that period was like. That's when they were trying not to make connection to the ground. But most, like on a quality piece of gear now, they're using metal XLR, and typically, so for example, even ones that have like nylon bodies, for example, now, if you look at the mounting hardware, usually one of the 2 screw holes will have a metal contact in there.
Inside the plastic where it screws
inside the plastic. So when you screw it in, then it's hopefully making a connection to the chassis. But, maybe you should scrape the paint off. There's one piece of gear that I have serviced fairly regularly, and one of my little mods is on those 4 screws that hold the 2 input and the 2 output XLRs on. Not even on all 8 screws, just the 4 that have that contact on them. I put a pretty aggressive star tooth washer underneath that screw when I put the XLRs back in, just to make sure that the screw is actually making it through the paint into the metal.
Ike, I got to be mindful of your time here, Ike. I want to thank you so very much for giving us an insight into a preview of what's to come for noise, I guess, in our program. Thanks, Ike.
Thanks for having me.
It's always a pleasure to pick your brain, and I look forward to the nonstop amount of stories you're able to provide this section, Ike. So,
well. Yeah,
have a great summer.
Keep an eye on my LinkedIn feed. There'll be a few more articles coming up. There's a couple more this month, actually.
Perfectly. Perfect, Ike. All right.
Okay. Talk soon. Thanks.
For more information on the Toronto Audio Engineering Society, go to TorontoAES.org. There you will find notifications on our upcoming events, past events, Masters of Audio, and our member showcase. The Toronto AES is brought to you by Solotech, Gear Audio, Sonotechnique, Bell Media, YSL Pro, Electrosonics Canada, BRTB, Global USS, Adamson, Lawo, avshop.ca, Q5X, and the executive team of the Toronto Audio Engineering Society. I am joined by a friend of mine, Warren Beck. Warren, how are you?
Doing well, thanks. How are you doing over there?
Warren, you are the broadcast specialist, technical support, YSL Pro Audio, but you come from a background, an upbringing of audio. Who are you, and what do you do, Warren?
Well, I do as little as possible, and I'm really able that. My father, of course, the engineering brain behind Beck systems that one can very successfully argue shaped how we have audio today in many ways. And I learned at his side and at the side of some great minds, Jimmy Fong, Weimin Fong, Wei Kung Wong, and some non-electronic people like Erwin Schwalder and Jeremy Bell. Sorry, not Jeremy Bell. Jerry Bell.
Jerry Bell, yeah.
Yeah, he taught me well how to get my fingers out of the way to do a straight line with a ruler. Sylvia Frantone, even, she's an AES and a SIPTI person, so
yep.
She's listening. Credit out to her.
Well, you grew up with audio. You grew up with audio around you, and you're a musician.
Yes, I did tour. I played on records and all that nonsense. My grandfather had a radio station, CFGO in Ottawa. Yeah.
So you're a guitar player.
Yes, I started a week after my 5th birthday, so for a long time I've studied the instrument. Yeah.
So you've got guitar pedals. You design guitar pedals. You do a whole bunch of stuff.
Yeah, I got tons of pedals, amplifiers, noisemakers, also outboard effects, equalizers, compressors,
the gambit,
color, sound.
The gambit, Warren.
So wants it, they want to pay me enough, I do it.
so you repair, you do technical consulting for YSL Pro Audio, and why is broadcast and that type of technical understanding, like that super deep technical understanding, such an important thing for the kind of work that you do?
Oh, yeah. Recording is the recording environment, making records. I hesitate to use the fashionable phrase of industry, but it is a lot more simple. It leverages technologies that other industries, other elements of the marketplace of media transportation, media delivery have already worked out. So when you're dealing with the broadcasters, they work hand in hand with the telephony industry to give quality sound and picture at a reasonable rate. So it's very high level. How can we do it with what we've got, sort of thing? If we don't have it, let's make it or figure out how to make it. You're involved in a lot of that, paving the way of new standards, new ways of doing things. In the recording industry, kind of at the bottom of this pyramid or this tree, what have you, they benefit from a lot of that technology. They don't really create, they're not innovators. They didn't make the Studer Mark III A80 tape machine. They didn't make the U87 or the U89. They use them. It's how they use them that makes them very special compared to broadcasters.
Well, and that, to your point, it comes down to the telephony industry, and now we're stealing IP technology from the IP industry too. So we're leveraging our cohorts, and totally. we're not reinventing the wheel. You can't
repurposing the wheel.
Yeah, exactly. So
and sometimes you do invent the wheel. Definitely the broadcasters were there with Dad saying, no, we want it to perform this way. We're looking for this dynamic range. We're looking for this sound. We're looking for this noise. And yes, there have been times when the broadcast industry has invented things. So yeah.
Well, Ward Beck, it's no secret I'm a fan.
Really? No. Show everybody your tattoo. Come on.
No, I don't have any tattoos.
This is not for children, people. This is for adults only.
But no, we're talking metric tons of the product.
Yes.
But Ward Beck, they did something interesting to capture the noise. It was a big metal box that had balanced wire in it. What would tell me about the big metal box that had balanced everything on it, and why did they do such a thing to control noise?
Well, it's a philosophy. That's all it is. Do you like Coke? Do you like Pepsi? Do you like Tab? RC Cola? Find the one that you like. So Dad learned what he learned, worked with the people with whom he learned, from whom he learned rather, and he came up with a philosophy, and a whole bunch of people in the world, not just Canada people, in the world really like that philosophy. They bought into it, and Ron and Dad were busy as all get out for 20 odd years. if not longer, because remember, it started before 68.
Well, hundreds of consoles, thousands of units
Thousands, tens of thousands.
Yeah, like it's
all around the world. South
Yeah.
Africa, China, South Korea, England, whatever, everywhere in the world, our stuff was. World's largest console. That was ours. That was sold to Pathé in France.
And these are bespoke things. We're talking about bespoke systems.
That's how we interpret it today. Back then, it was the right thing to do. It wasn't bespoke.
So compared to today's technology, you're dealing with self-contained things. You're dealing with digital stuff, and you don't have that old transport medium, and you don't have those old limitations. What are some of the things that are happening with new technologies that are different than the way they used to do things?
It's a very exciting time to be part of it, because I did have a toe, if you will, in the old way of doing things. Yeah, I was a kid, whatever. I had a toe in it, so I was exposed to it. Later on, I could reflect upon it, learn, and understand.
Totally.
Now I'm in the time where it's IP, which is where you are, up to about here somewhere with IP. And it's so radically changed. I think it's very interesting that it's changed from tube to transistor. I wasn't part of that, but I was definitely exposed to the transition of transistor to integrated circuit.
Right.
And now it's moved beyond that, even though ICs are still there and transistors are still there.
Yeah.
But I think the evolution is a wonderful thing to experience. And you get to see new challenges. Some of the people, not saying you, because I know you, and I know from where you came, but people like you, they don't have the experience of a 12AX7 going. They don't have the experience of a capacitor, what it sounds like when it dies. Here's a surface mount capacitor.
Yeah. There's no user serviceable parts or user interaction with the technology anymore.
Not at all. And that's what you want, because my God, it's so convoluted and complex.
Yeah.
You can't afford it. Your car, come on. You can't make your car anymore. You can't tune up your car anymore.
Right.
You need a computer.
Well, and it's software driven. So YSL, one of their big products and brands is the UAD stuff, and they do something different. They emulate noise. So is it almost like hypocritical that like half of your career or half of one's career is spent reducing noise, and then the other half of a career is spent like systematically emulating noise? I'm not saying that is your career, but like this trend of like the trend of an industry is like, well, let's get rid of all the noise and now let's emulate it. What's happened? How did that happen to the industry?
Well, I think you're remembering the little essay that I have. Somebody used to have on a website in poor taste that was done in tongue in cheek, where mother said, "You're a bad boy. Your father spent his life getting rid of noise and distortion, and you're asking him now to generate it." Yes, my father spent a lifetime getting rid of noise. That's what we do. We want to get rid of extraneous sound that will interfere, reflect, impact upon the desired program material. I think now it's as hard as it was with thermal noise from a bunch of tubes, if not even more difficult, because no longer is it a mechanical thing, where you can put a Faraday cage around it.
Noise. There's noise. Another
my father, birthday today.
Hey.
Or you can have a mechanical who's-its to go around it to reject the noise, or push a button to reject the noise. And that can't be done as easily anymore. You have to run algorithms and software to combat noise that's generated from algorithms and software. Kind of like, to use a brand name, Cedar. They have a way to extract noise from things.
How did no, it's all right. I appreciate your time. Your time is valuable, and I appreciate it. You spoke on Cedar there, and Cedar. How did they get started? And they were hackers, right?
That's it's a little harsh and a little critical, but they had a mission. They had these wax cylinders in England and university, Cambridge, and I don't know if you've ever seen a wax cylinder. Most people listening to this probably don't know what they are, but it was a device that looked like a toilet paper tube with wax on it, beeswax on it. It was kind of hard, And sound was recorded on that cylinder, on that wax. And the wax, it was the medium, just like bumps on a vinyl record. And time, heat, life degrades and degenerates that wax cylinder, and also it has its own inherent noise. Cedar came up with a way to use some filters backwards to lessen that noise, but keep the desired program material prevalent, focused, and present.
Is the air part of a signal?
Yes.
Like, so
it's a transmission medium. Yeah.
So when you have a microphone, like is a microphone an antenna for air, and is some of that air lost in some of these processes, and what are some of the better things we can do, or are we at a tipping point where some of this medium is just going to get lost? Like you say, you have mechanical degradation of things, you have sonic degradation of things, you have buildup of things. Like, are we approaching a tipping point of being able to recover some of this medium?
Well, a microphone is a device to capture mechanical impact of air waves, of sound transmission. It's all the same thing, just different words to describe air movement. Where it's a variable capacitor, if it's a condenser microphone, whether it's I don't have any here, sorry, little pieces of aluminum for a ribbon microphone, or a speaker cone for dynamic. Some of these elements need more velocity to get it to do its job, to transfer the sound waves into electricity. The microphone will always be there. Maybe in a different version, maybe in a different state, but for now, this is what we have.
Right, we've got dynamics, we've got capacitors. You said variable capacitor. Why is it? This is like, so there we're capturing capacitance and we're converting that into a current and into a voltage somehow. Then another way we have a coil moving. You said there's might be other ways.
Wiggling in a magnetic field, right? Typically three ways.
And those things have noise themselves, right? They generate noise themselves.
Yep, and that's interpreted as color. That is also interpreted as mechanical. I don't know if you can hear the chair wiggling up. There could be noise like that too. So remember, the coloration that this microphone gives over that microphone is also in of itself noise, because it's equalization, right? In some of this
emulation technology, I've seen a lot of microphones show up, and when you grab a 58 or a microphone, it has a physical presence in your hand. It has a resonant chamber, and it has a noise, like it has a self noise. Are microphone emulations starting to take that into consideration, and is that part of the noise profile, part of the sound?
Certainly it is. If the noise of the 4038 is there, when that ribbon was not put in properly square and is slightly askew, and it's scraping the side of a magnet, that will result in some frequency degradation. That was captured by, to use a brand name, Townsend Labs, when they emulated the microphone characteristic for that 4038. Mm-hmm. You can have a vintage Neumann U47, which I was given on Friday, that I told you about. The thing is not quite as old as me, but it is old. It is going to have tube noise. This one has a new Vistor tube as opposed to the Telefunken tube. This is going to have diaphragmatic noise. This is going to have reflection noise from within the head basket. It all is a way to color and characterize the sound of the program material to make Ella Fitzgerald sound as beautiful as she does. Frank Sinatra, to make him great. Nat King Cole, to make him the epitome of all vocalists.
And those microphones, they have a certain magic, but that magic is, there was a newness in that microphone, right? Like,
so you're comparing to crystal microphones and other things. So as time goes on, you get better and better, right?
So speaking of microphones, you're quite you're a fan of microphones. You're an expert on microphones. All things
I'm a fan of them. I wouldn't say an expert.
They're springs, right? Like all microphones are, some kind of spring. What happens and what kind of noises are introduced in the diaphragm as it springs back and forth between, its state of rest and its state of excitement? And what kind of stuff have you run into in your career? And, you've taken apart hundreds of microphones. What kind of stuff, what kind of noises have you removed from people just right at that physical level?
You've been able to reduce, to a degree, eliminate, at least on a perceptible level, resonancies that occur within the the diaphragmatic chamber where the diaphragm is, because you can dampen the environment so reflections don't come into play. You can retension the ribbon if it's a ribbon microphone to have an improved low frequency response. So you're eliminating wow and flutter, kind of like on a record, by retensioning the ribbon in a ribbon element. On a dynamic microphone, you have buzz and rub just like you do on a speaker, because it's the same darn thing.
Yep.
Just a lot more delicate and used backwards. So, sorry, by tensioning the capsule, by replacing the plastic medium on which the aluminum or gold is sputtered, plated, you can have a different characteristic of response. One's faster, one's slower. Therefore, the equalization curve will be different, and that could be appreciable or non-desirable, but you are also modifying how it's making its own mechanical noise. How that diaphragm moves back and forth. Is it more rigid and stiff, therefore more efficient, more lax, prone to a little sloppiness and a little distortion, perhaps?
I get that, and people talk into it and they get humid and, they get heavier, they get, the breath.
Or it's July versus February, You got environmental humidity issues as well. Heat.
No, yeah, heat. It plays a huge role into it. All of these factors definitely play into it.
Heat's your worst enemy. In vintage times to now, it's your worst enemy. It always induces noise. It's always thermodynamics of some sort.
So yeah, and that was the electronics, the heat within the electronics, will generate that noise, man. Well, Warren, thank you so very much for your insight into noise and what. Just briefly, you're a pedal designer. As a guitar pedal, like I've plugged guitar pedals in, I've integrated guitar pedals with other pedals. It just seems like it's a minefield of buzz. And manufacturers are navigating these, kind of buzz and hum feels. Like you're dealing with batteries, you're dealing with power supplies, you're dealing with, plugs that turn power on and off. What kind of noises are just like inherent in some of the equipment that we integrate into our music creation process?
Well, you have your basics. We'll start with RF and EMI. You always have that, always playing a thing. You have electromechanical switches, whatnot.
Right, clicking.
You have thermodynamics. As things heat up, they behave differently. They pop if they're a tube or transistor. You can get slightly different responses over time. Some of the components, as they get hot, like an electrolytic capacitor, will degrade, become more of a resistor. So you get different characteristics as it warms up. All those are a problem simply because the guitar design is flawed. If it's an electric guitar, it's flawed from the principle because it's a high impedance. It's based upon a moving coil of a phonograph. It's a stupid idea. It's the worst idea possible. It's stuck, and we love it. I have vintage PAFs from Gibson, and P90s. I think are the best things that ever lived. Yeah. But man, in a bar with a P90 and a mirrored back behind the bar is hell to be opposite that.
Yeah, no, and that's the thing. But they're just antennas. To your point, they're an impedance thing.
The coil becomes an antenna, so they are antennae of themselves. Yes, but they are not antennae to pick up radio stations, RF and whatnot. They are tuned to a degree to do within a certain bandwidth, a certain frequency range. When they degrade, they can pick up more and more stuff. You can use them as a microphone.
Yeah, pickups, yeah. Well, we'll keep digging, Warren. I'm not to the bottom of this noise thing. It seems to be a never-ending rabbit hole.
Well, look where you work. Of course it is. It's the foundation of the institution.
Well, I got to start from the ground up, right? So I figured noise is a ground up kind of problem. So we'll get to it.
Well, as I said, I know you, and that's a double entendre by saying ground, and you know what I'm saying. But ground is very important to have a proper grounding scheme in your electronics to eliminate noise from electricity.
So, all right. Now, you said the word scheme, and you have my full attention.
Oh, gloves are off.
Okay, so let's talk about pedal board. right? You know, sure, it's there to make distortion and delays, et cetera, but unwanted noise is, you know, like it's like a common thing with pedal boards and guitars and stuff. So you said star, point, common, ground. You know, like if you were designing the perfect guitar rig, what would it look like? And if you were designing a studio in 2 minutes, if you had to give the best advice to make the best guitar pedal and to make the best recording studio, what would you do, Warren?
In the best broadcast facility, I would encourage people to study the grounding of the environment where they're going to operate this guitar pedal, this studio, the best they can, and practice proper grounding techniques. But go digital. Get rid of the analog stuff. Go digital.
Man, that's a 2021 answer if I've ever heard one. Yeah,
I'm trying. You're asking me to update myself. I'm trying.
You know, man. So yeah, it's a different kind of noise there. Warren, thanks for.
I would totally say, let's take a look at what you're trying to do and update it. You can record the noise, put it out of phase, and go, and it's gone.
Yes.
That's the oldest trick in the book with a recording studio.
Well, it's you know, when you get into the digital side of things, it's perfect. And then when
it's not perfect. It's just a more clear picture. It's a different side of the coin. It is not perfect.
Okay, so let's say it's an accurate sample. I love accurate
samples. It's a different level of accuracy because tubes sound so pleasing with the second, third order. The digital can sound very sterile and icky. So, is it perfect? No.
So icky. When you say icky, you know, well, let's translate that into power supply limitations.
Swear, okay.
Okay, all right. Well, let's say it's power supply limitations of a piece of audio equipment. Let's just say icky
in that paradigm, sure.
Okay. So let's say the modern piece of audio equipment compared to pieces of equipment in the past are operating at a much lower voltage, and they're not
as hot.
They're not as brutish as they once were, you know, in the industry. You know, you used to be able to like drive 3 kilometers worth of wire because
that's why there's a balanced cable, so you can do stuff like that. Yeah.
So then, you know, what are electronics different now that now that the voltages are different and the capabilities and receive capabilities are not what they used to be? Because, you know, there's an impedance mismatch too of what used to exist and what now exists. How are people doing it wrong, and what kind of problems are you experiencing on the repair side, for example? Even you have a great insight there.
Well, again, I'll try to be polite. A lot of people are dumb. You said impedance issues. You have typically, rule of thumb, a microphone's 150, 200 ohm impedance. Line level 600 ohm. Why do I have to have another amplifier after a ribbon microphone to go into and drive 150 ohm load? Like, it's an impedance mismatch. Should be a 50 ohm load amplifier. They're doing it wrong. They're trying to use a low noise amplifier to boost the signals. We have boosters. The modern spin on things forgets or is ignorant of or unaware of a lot of the past. You have to bring it forward and understand that your preamplifier has to be 600 ohm, 150 ohm, 50 ohm. Shut the front door is what it's got to be. You don't need a booster there to boost up your ribbon microphone. It's just put the impedance match in. By doing so, you are going to lose a lot of this hiss, hum, extraneous sound that you don't want. Therefore, you're going to lose the noise.
You know, Warren, that's great. We're gonna end it there because I gotta bring in other people here and that, you know, I got, you know, another couple guests who are going to talk about impedance mismatches and transformers and stuff.
No problem.
Warren, thank you so very much. You be well.
Thank you, Anthony. You too. Be good.
For more information on the Toronto Audio Engineering Society, go to TorontoAES.org. There you will find notifications on our upcoming events, past events, Masters of Audio, and our member showcase. The Toronto AES is brought to you by Solotech, Gear Audio, Sonotechnique, Bell Media, YSL Pro, Electrosonics Canada, BRTB, Global USS, Adamson, Lawo, AVShop.ca, Q5X, and the executive team of the Toronto Audio Engineering Society.